Hello students, I am Pallavi Bokhe from VPK BIT Baramati. Welcome you all to this video lecture. This video lecture will focus on the fluid mechanics unit 1 fluid properties. Now before actually going to the fluid properties or understanding the various properties of the fluid, first we will understand what is meant by fluid. Now matter mainly classified into two states. First one is solid and second is fluids. Now compare it, if we compare with the solid fluid, in fluid the space between molecules is relatively large. The intermolecular cohesive force in fluid is less. Fluid cannot resist tensile force or very less and can resist compressive forces only when it is kept in a container. Fluid changes its shape and flow because of inability to resist shearing stress. The fluid undergoes continuous deformation. Now, any substance which can flow is called fluid. Now, first we'll understand what is meant by substance. The substances which have finite mass, which occupies a space and which is tangible. So, and the flow is that if the position of any particle changes with respect to time, then it is called as flow. So, any substance which can flow is called fluid. Now, fluid mechanics is that branch of science which deals with the behavior of the fluids, liquid or gases, at rest as well as in motion. Thus, this branch of science deals with the static, kinematics and dynamic aspects of the fluids. The study of fluids at rest is called fluid statics, and the study of fluids in motion where pressure force are not considered is called fluid kinematics. And if the pressure forces are also considered for the fluids in motion, that branch of science is called fluid dynamics. Now fluid has various properties. Now we will see one by one. So first property is mass density. Density or mass density of a fluid is defined as the ratio of the mass of a fluid to its volume. Thus, mass per unit volume of a fluid is called density. Here we can observe that mass density rho is equals to mass per unit volume. It is denoted by symbol rho, and the unit of mass density in SI unit is kg per cubic meter. The density of liquids may be considered as constant, while that of gases changes with the variation of pressure and temperature. Next property is specific weight or weight density. Specific weight or weight density of a fluid is the ratio between the weight of a fluid to its volume. The weight per unit volume of a fluid is called weight density, and it is denoted by symbol gamma. So weight density gamma is equals to weight per unit volume, where weight can be written as m into g. So this can be written as gamma is equals to, that is weight density is equals to rho into g. The unit of this weight density is Newton per meter cube. Specific volume. The specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass, or volume per unit mass of a fluid is called specific volume. Mathematically, it is expressed as volume upon weight. So this can be written as 1 by gamma, and the unit of specific volume is meter cube per Newton. This can be written as 1 by rho. So unit for this is meter cube per kg. Specific gravity, it is denoted as S. Specific gravity is defined as the ratio of the weight density of a fluid to the weight density of a standard fluid. For liquids, the standard fluid is taken water, and for gases, the standard fluid is taken air. Specific gravity is also called relative density. It is dimensionless quantity and is denoted by the symbol S. If the specific gravity of a fluid is known, then the density of the fluid will be equal to specific gravity of fluid multiplied by the density of water. For example, the specific gravity of mercury is 13.6, hence the density of mercury is 13.6 into 1000, that is 13,600 kg per meter cube. Now here we'll see one numerical based on the above properties of the fluid. The numerical is a 400 ml of a certain liquid weight 9 Newton. Calculate the weight density and the specific gravity of the liquid. In this numerical, the given quantity is the volume, that is 400 ml, which can be written as 0.4 liters, and if we have to convert this into meter cube, so 0.4 divided by 1000, that is 4 into 10 raised to power minus 4 meter cube. We have weight, that is 9 Newton. To find weight density and the specific gravity, now we have formula for weight density, that is equals to weight upon volume. So weight is given and volume is also given. From that we can find out the weight density of the liquid. So 9 upon 4 into 10 raised to power minus 4, that is equals to 22,500 Newton per meter cube. So this can be written as 22.5 kilonewton per meter cube. The next quantity that has to find out is specific gravity. Specific gravity is weight density of liquid divided by weight density of water, that is 22.5 divided by 9.81, so that is equals to 2.294. so this is a very simple numerical. We'll see one more numerical. 2 liter of petrol weighs 14 Newton. Calculate the specific weight, density, specific volume and specific gravity of petrol with respect to water. In this numerical, the given quantities are volume, that is 2 liters. So that is equals to 2 into 10 raised to power minus 3. And weight, that is 14 Newton. We have to find out the quantities, specific weight, density, specific volume and specific gravity of the liquid. Here specific weight is gamma, that is equals to weight upon volume. So this we can simply find out by substituting the values of weight and volume, and the answer is 7,000 Newton per meter cube. Specific weight is equals to mass density into acceleration due to gravity. So by substituting the values, we can find out the mass density, that is equals to 713.56 kg per meter cube. Specific volume is Vs, that is equals to 1 by rho, that is 1 by mass density. So specific volume is equals to volume by mass. Here mass density we have already calculated, so from that we can find out the specific volume. The answer is 1.4 into 10 raised to power minus 4 meter cube per kg. And last quantity that we have to find is specific gravity. Here the density of liquid divided by the density of water. So substitute the values of density of liquid and density of water, we'll get the specific gravity of the liquid, that is equals to 0.7135. so in this way we can find out the different properties of the fluid if some parameters are given in the numerical. So thank you. In next video we'll see the another property of the fluid.